It's one of the oldest life forms on Earth. Older than dinosaurs, older than trees, older than almost anything that has ever lived. For over 3.5 billion years, it has quietly existed in warm, alkaline lakes around the world, and twice in human history, on 2 different continents. Completely unconnected civilizations independently figured out the same secret. This strange blue-green algae could feed an empire. Today we call it Spirulina. NASA has studied it as food for astronauts. Health stores sell it in powder form for absurd prices. But its real story begins centuries before any of that, floating on the surface of a lake in the Valley of Mexico. This is the history of Spirulina. Our story begins in the 14th century, in the heart of the Aztec Empire, on the shimmering surface of Lake Texcoco, the great lake that once surrounded the Aztec capital of Tenochtitlan, the city that would eventually become Mexico City. The lake was alkaline, warm, and mineral-rich, exactly the kind of environment where Spirulina thrives, blooming across the surface in thick blue-green mats. Aztec harvesters noticed this strange bloom, and through observation and trial, learned to collect it. Using fine nets, they'd skim the algae from the water's surface, then spread it out on the ground under the intense Mexican sun to dry. What emerged was a hardened blue-green cake, which the Aztecs called tequitlatl. This wasn't a minor food source. Spanish chronicler Bernardino de Sahagún, documenting Aztec life shortly after the conquest, described tequitlatl being sold in marketplaces as a staple food, cut into cakes, sometimes flavored, and eaten much like a form of bread or cheese might be eaten elsewhere. For a civilization supporting hundreds of thousands of people in a lake-bound city with limited farmland, this protein-dense, easily harvested algae was a genuine nutritional lifeline. Here's where the story becomes genuinely remarkable. Thousands of miles away, with no contact whatsoever between the 2 civilizations, a strikingly similar discovery was happening around Lake Chad in West Central Africa. The Kanembu people, living along the lake's alkaline shores, had also learned to harvest the same blue-green algae blooming in the shallow waters near shore. Using cloth filters and shallow basins, Kanembu harvesters would scoop the algae-rich water, filter it, then spread the thick paste onto the hot sand to dry in the sun, a process remarkably parallel to what Aztec harvesters were doing an ocean away. The dried product became known as dihe, pressed into cakes and used as a key ingredient in local dishes, particularly a traditional sauce served with millet. 2 civilizations separated by an ocean and centuries of independent development had both looked at the same strange lake phenomenon and arrived at the same conclusion. This algae was food, and a valuable one. It's one of history's most striking examples of convergent discovery. But this knowledge nearly vanished entirely. In Mexico, Spanish colonization dismantled much of Aztec urban and agricultural life. Lake Texcoco itself was gradually drained over the following centuries as colonial and later Mexican authorities sought to control flooding and expand the growing city. The very habitat Spirulina had thrived in was slowly disappearing. The practice of harvesting tequitlatl faded from common knowledge, surviving only in scattered historical records and colonial-era accounts. In Africa, by contrast, the tradition never fully disappeared. Kanembu communities around Lake Chad continued harvesting dihe quietly, generation after generation, largely unnoticed by the outside world. It simply wasn't considered remarkable or newsworthy. It was just food, part of daily life for a community far from the attention of European science. For roughly 4 centuries, Spirulina's story went dormant in the historical record. It would take a coincidence and colonial-era industry to bring it roaring back into global awareness. The rediscovery begins unexpectedly with soda ash. In the 1940s, a French industrial company was extracting sodium carbonate from Lake Chad's alkaline waters for manufacturing purposes. Workers repeatedly noticed a strange, persistent problem. Their extraction equipment kept clogging with thick, blue-green sludge. Rather than simply being an industrial nuisance, this sludge caught the attention of a visiting botanist. In 1963, French phycologist Jean Léonard led a research expedition to Lake Chad and observed something that stopped him in his tracks. Kanembu women were harvesting and selling dihe in local markets, the very same clogging sludge that had been frustrating industrial engineers for 2 decades. He recognized it as a member of the Arthrospira genus, closely related to organisms studied separately by researchers examining Aztec-era Mexican records. Word of the discovery reached researchers investigating Mexico's Lake Texcoco industry, where a separate chemical extraction plant had, coincidentally, encountered the exact same blue-green nuisance blooming in their soda ash ponds. Scientists cross-referencing both discoveries realized they were looking at essentially the same organism that 2 ancient civilizations had already domesticated as food, centuries apart, without ever knowing about each other. Nutritional analysis revealed something extraordinary. Dried spirulina was as much as 60 to 70% protein by weight, an astonishingly high concentration for any food source, let alone one that could be farmed in shallow, otherwise unproductive alkaline water. This protein density caught the attention of an unlikely group: space agencies. During the 1960s and into the 1970s, as the United States and Soviet Union raced toward long-duration space missions, both nations' space programs began seriously researching closed-loop life support systems, ways to grow food, recycle oxygen, and manage waste in the confined environment of a spacecraft or space station. Spirulina became a serious candidate. It required minimal water and land, grew rapidly, converted carbon dioxide into oxygen through photosynthesis, and packed remarkable nutrition into very little mass. A critical consideration when every kilogram launched into orbit carried enormous cost. NASA conducted research into spirulina as a potential component of long-duration space nutrition, and the European Space Agency later included it in experimental closed ecosystem projects such as Melissa, examining how algae could form part of a self-sustaining life support loop for future deep space missions. While spirulina never became a routine daily staple for astronauts the way freeze-dried meals did, its association with space food research supercharged public fascination. A 500-year-old Aztec lake harvest was now being seriously discussed as the future of interplanetary nutrition. Today, spirulina is cultivated commercially around the world in large open ponds across the United States, China, India, and beyond, grown deliberately in the same kind of warm, alkaline conditions that once occurred naturally in Lake Texcoco and Lake Chad. It's sold today as a powder, tablet, or capsule, marketed heavily under the Superfood label, praised for its protein content, its concentration of certain vitamins and antioxidant pigments, and its relatively low environmental footprint compared to traditional livestock farming. And it's worth being direct here. While spirulina is a genuinely nutrient-dense food with a remarkable, well-documented history, many of the more dramatic modern marketing claims around it go well beyond what current scientific evidence actually supports. It's not a proven cure for disease, and like any supplement, it shouldn't replace medical guidance or a balanced diet. What is undeniable is the trajectory of its story, from an Aztec lake harvest and a West African fishing tradition, independently discovered continents apart, nearly lost to colonization, rediscovered by accident through an industrial nuisance, studied as space food, and now sitting in smoothies and supplement aisles worldwide. Spirulina's journey is one of the strangest in the history of food. Not one civilization's discovery, but 2, arrived at independently forgotten, and then found again almost by accident. It's a reminder that some of the most cutting-edge ideas in modern nutrition were quietly solved by ancient communities centuries before any laboratory existed to study them. If you enjoyed this deep dive, subscribe. Every week, Herb and Lori uncovers the hidden history behind the herbs and superfoods sitting quietly in your kitchen cabinet. Next week, the deceptively simple story of how a leaf from South America overturned the entire global sugar industry. The strange history of stevia.